so 1.1 is explain transformations, and then by the end of today, I want you to know how to do two things. Okay, so the first thing is, I want you to be able to apply transformations to points and sets of points. Okay, so apply transformations to points and sets of points. Do you guys know what transformations are? Do you guys know some of the types of transformations? Sound familiar? Yeah. Yeah, reflection's one. Mm-hmm. Yeah, translation. And those are the two that we're going to focus on today. You guys might have also done like a rotation before. Translation and reflection is what we're going to focus on. Okay, and we're going to interpret transformations with graphs. And then one thing that might be a little bit different in this class from some of your past classes, when you get into the honors level, it's not just about can you do the problem, but can you explain how to do the problem and developing your mathematical language. So we're going to be going over some things today that you're going to see in your textbook. There's a lot of transformation rules that have a certain mathematical language to them, so we're going to work on that as well. All right, so I'm going to show you page 7 in the textbook. So if you have yours and you just want to check out page 7 to make sure it is the page 7, the same one as I have, feel free. See a lady in a recording studio, you know that you have the right one. Okay, so the translation of points, right? If you're given a point, okay, and then you need to give the coordinates of the translated point, we're going to look at the directions. So the first one is 4 units to the left. Okay, now on a graph, yeah, we're just going to move it 4 to the left. And then we're going to identify that point. So you're always welcome to graph it, even if a graph is not there. You can also subtract. Does the moving left, what axis does that affect? The x-axis, right? X is horizontal, so you can just subtract 4 from the x. You guys remember that stuff? Is it coming back to you? Right? Right and left will be horizontal. Okay, so for right you add, for left you subtract. And then the second one is 2 units right and 3 units up. So the 2 units right, you would be adding to the x. The 3 units up, you would be doing what? Adding to the y. And if it was down, you'd be subtracting. Okay, so again, feel free to use the graph when you're doing the translation, but you don't have to. If you know the rules, you can just perform the translation, okay? All right, so example 1 says to perform the given translation on the point, give the coordinates of the translated point. So you can see one of the strategies that I use as I am reading directions. I do like to highlight what I'm expected to do, and then I try to box in the point that I have. So if I'm performing the translation, on this point here, and then I have to give the coordinates of that new point. Okay, so for A, I'm gonna tell you what the problem is. Okay, so for A, we're going to be moving it 4 units to the right. For B, we're going to be moving it 1 unit left and 2 units down. So So yes, I want you to put in the direction. I don't just want you to write down the answer, because I want you to be able to look back at these and say, oh, for 4 units right, this is what I did. Okay, and again, you can graph it, you can draw a graph if you need to, but I'm going to give you a minute to do that, and I will walk around and check out your stuff, so if you need some help. And then make sure when you do your point that you use your proper symbols, that you have your, if it's a point, you have the parentheses around them. Do both A and B. All right. Seth, can you tell me what your strategy was for part A? How did you find your answer? Uh-huh. Yeah. And you just have to add 4 to what? Yes. Okay, so 4 units right is affecting the x coordinate, right? So you could just add 4 to that. There you go, 3, 3. Okay, for the 1 unit left, okay, that's going to affect the x coordinate. But then the 2 units down is going to affect the y coordinate. So if you want to do this without graphing, I set it up like this, right? I have my point. I say, okay, if it's left, I'm subtracting. Okay, and then for the 2 units down, I'm subtracting from the y. All right, so then I have -2, +1. Okay, thumbs up if you're feeling good about that. Alright, so I told you guys there are going to be some of these rules. Okay, so you're going to see a bunch of these rules in your book. And we want to know how to apply them. These are things that you would see on a formula sheet. So the first thing we have is a horizontal translation. Okay, so horizontal goes left and right. It's the x-axis. So what happens is you start with a point xy. And then the arrow is saying, okay, I start with xy, and this is what happens. So with the horizontal translation, you add a value, any value. In this book, they refer to it as h. That's the constant term that they use, comma y. And then there's stipulations. So you are going to be going left if h is less than 0. Well, what does that mean, h is less than 0? What kind of values are those? Yeah, negative. Yep, good. Okay, so this is something that you would see in the text, and then this would be something that you want to apply, right? Like, oh yeah, if it's less than 0, it's a negative number. And then if you're going to the right, your h value would be greater than 0. So again, you would see in the text, h is greater than 0, and then what you want to be thinking to yourself is, oh, that's a positive number. So when h is positive, I'm going right. When h is negative, I'm going left. Okay, so we have horizontal translations, but we also have what type? Vertical, yes, good. Okay, so a vertical translation again, you start with that xy. Okay, and then it's x, comma. Now for the vertical translation, they use the variable of k. Now those are subjective. They change based on the textbook, but I'll be consistent with what our textbook uses. And just like we had special cases here, we have special cases for this one. So if you're going up, the value of k has to be what? Positive, so greater than 0. Yeah? And feel free to write positive with that. You want that extra reminder. And then it will be down if k is less than 0. Okay, so that is the translations, both horizontal and vertical. The other type of transformation we're going to talk about today are reflections. Do any of you remember the rule of the reflections? It's okay if you don't. We're going to figure it out. Okay, so the first one, we're going to do a reflection across the y-axis. So I'm going to give you a couple points, and then I'm going to have you do the reflection. So the first point is -2, 2. And the second point is -3, 4. And you guys can connect those. You can use your straight edge. I know this one's kind of small. How many of you are pretty confident that you could graph the reflection? Okay. When you graph it, you can either use 2 different colors. If you don't have 2 different colors, just make the reflection a dashed line instead of a solid line, so you can see the difference between the 2. Okay. Sometimes I also highlight the line of reflection. So if it's across the y-axis, okay, that's your line of reflection. And then I just want to see if you guys can graph what the reflection will be. And then label those points. So once you graph it, label the points. And then I want you to start thinking about the rule. What's the rule going to be? Have the graph down, and then once you graph it, I want you to write the 2 points, because I want somebody to tell me what the rule is. Okay, and some of you might have used this to help you graph it. Each reflected point is the same distance from that line of reflection. Because I could see some of you counting, that's great. This is 1, 2, so then you just went 1, 2 in the opposite direction. This was 1, 2, 3, so then we went 1, 2, 3. That's excellent. Okay, but now let's look at the points. So I went from -2, 2 to +2 and +2, -3, 4 to 3, 4. So can everybody articulate what happens when you do the flip across the y-axis? Yeah.
For the numbers, you just multiply the x by either one.
Yes, okay, so the y is going to stay the same, but the x gets multiplied by -1. The x coordinate is called the opposite. Okay, so the x coordinate is opposite. So same value, it just changes signs, right? In this case, we started with a negative, so it went positive. And then we're going to write the rule, okay? So remember, the rule always starts with xy, and then it goes to, do you guys feel like you could write the change in the rule? Or do you want to do this one together? Good talk. We'll do this one together. So we do the opposite of x, y stays the same, and then I'll have you do it for the next one. Okay, now for the next one, we're going to start with this guy here, the 2, 2, and the 3, 4. And then I want you to perform the reflection across the x-axis. So again, sometimes I just like to highlight this. That helps me when I'm coming up with the distance. Okay, so I want you to graph the reflection, and then I want you to see if you can write the rule this time. Alright, so just like with the first one we said, the x-coordinate is opposite. For this one, it's going to be the y-coordinate that's opposite. So if you wanted, you could use that rule right away if you didn't want to count, right? So the 2 is going to stay the same. It just becomes -2, +3, but then it becomes -4. Oh, and then like I said, if you have one color, you can use the dash to show the reflection. So this becomes 2, -2, 3, -4. And how did we do with the rule, you think? Doing good? Yeah, Julianne? Yes. So xy becomes x opposite of y. Good. Oops, sorry, there you go. Okay, now we are going to apply some of these two graphs. So we're going to use a table to perform the transformation, and we're going to use the same coordinate plane as the original function. We're going to be making a table. I actually changed it. I decided we were just going to do 3 points included instead of 4. Okay, so what's going to happen for your practice problems is you'll be given an original function, and then you'll perform operations to that function. So I'm just going to give you the general, it looks more like that actually, the general outline of the original function. I'm going to do that over. It looks like this, okay? And your points are going to be -2, 0, 0, -2, and then 2, 0. And we're going to graph this on parts A and B, which are on the next page. So this is just going to be a rough sketch. So when you're doing your assignment, you'll be given this one graph, and then you're going to do multiple transformations to it in different problems. Okay, so we're going to start with one, and then we're going to apply it. So if you guys want, you can flip it over. So for part A, we're going to draw this on there. For part B, we're going to draw it on there. So the goal is to see how the transformations affect the original. So -2, 0, 0, -2, and 2, 0. I'm going to draw it with you as well, so if you just want to put those points on there for both of them, and then we can connect them together, we'll connect it with the straight edge. Okay, so -2, 0, 0, -2, and then 2, 0. Okay, so we don't know what we're doing yet, but we do know this is the original function. So -2, 0 is right here. 0, -2, 2, 0. So you'll notice as time goes on that I use the same format that your book does so that when you're looking back you have something to look at. And then we're going to connect these. And then this has a slope of 1, so it's going to follow this line here. So you guys can use your straight edge for that. And the original is going to be the same for both A and B. Again, that's similar to what you would see in your practice problems. Okay, so that's why we're just going to start with that for A and B. All right, and then for A, we're doing a translation of 2 units up. So the first thing I want you to do is just do the translation on the graph. The translation of 2 units up. And then once you get those new coordinates, that's what you're going to put in the table. Okay, so new coordinates are in the table. So you don't have to label the new coordinates on your graph because it's going in the table. And then if you are not doing them in 2 different colors, will you guys use the dash lines to connect them? Okay, so the translation of 2 units up, right? You can focus on these points, 1, 2. Okay, so now I'm at -2 up 2, so this becomes -2, 2. You could also, because the 2 units up is the y-coordinates, all you have to do is add 2 to the y-coordinate. Right, so if this is 0, -2, and I add 2, I'm right here at 0, 0. And then if I add 2 here, I'm at 2, 2. Okay, so now I'm going to connect them. So again, if you are not color coding, use the dashes so that we can see the difference. The goal is to see how the graph is being affected here. Okay, so if I were to look at this, I could see, oh, my purple's the original, and pink is the transformation. The entire graph moved up 2. There's no change in the shape. There's just a change in the position, so 2 units up. Okay, and then for this one, we're going to do a reflection across the x-axis. And again, you're putting the new points in this table. All right, so think about what the rule is, and then go ahead and apply it here. And remember, with the reflection, sometimes I like to highlight what the line of reflection is. That just helps me separate them. And if it's a reflection across the x-axis, remember, it's the y-coordinate, that's the opposite. Okay, so I know some of you are thinking, okay, like, what do I do with this? But a lot of you were able to get this one here, right? Because you go 1, 2, 1, 2, okay. Well, let's think about if the y-coordinate is opposite. The first point is -2, 0. My y-coordinate is 0. What's the opposite of 0? 0, right? Because it's not positive or negative. It's neutral, so it stays the same. So -2, 0, that's going to stay the same. Okay, and then the same thing, let's put this in here. So this would be 0, 2. Okay, so 0, -2 becomes 0, +2. And then this is going to be 2, 0. Now make sure that you put the arrows going the right way, because my arrow here, right, is 1, 2, so I know it's going to be like 1, 2 there. So the slope is still 1. We want it facing outward. So some of these points were on the line of reflection. What can we say about points that are on the line of reflection? What happens to them? They stay the same. Good. Okay, so if a point is on the line of reflection, it stays the same. of this stuff coming back to you? I know it's been a while. Right? Because your Algebra 1 would have been all online. Okay, so if you need me to go over something again, please don't be afraid to ask me. We're going to try to ease our way back into some of these things. Okay, so for C, it's asking how would our table be different if for part B we did a reflection over the y-axis. Okay, and then it says explain and show the difference using a table. Okay, so we have to do an explanation, and then we also have to use a table. So, do you guys need any more time for this part? Good. And really, I'll ask you guys that, and if you do need it, say something, and if you're good, just don't say anything like you just did. All right, so for the explanation, the explain part, okay, remember that we want, if it's asking you to explain, we want to be as specific as possible. We want to use complete sentences. Okay, so with a reflection over the y-axis, okay, with a reflection over the y-axis, the x-coordinates would be opposite. So let's do our table, and then maybe we can expand upon that. So if I were to make a table for that type of reflection, the x-coordinates are opposite, so instead of negative 2, 0, I would have 2, 0. And I'm just going to go in order, right? So negative 2, 0 would become 2, 0. What about for this one? 0, negative 2. Stays the same. And then 2, 0 would become negative 2, 0. Now really, if we look at these points, wait, 2, 0 is here, 0, negative 2 stayed the same, and then negative 2, 0 is there. So aren't these just the same points that we already have here? Yeah, if it's a reflection over the y, what would happen is the right side of the graph would reflect onto the left side and vice versa. Okay, the left side would reflect over onto the right. So it would look the same. Okay, so the graph would look the same as the original with the reflection. Okay, and we could just add that to our explanation. All right, now remember I told you in here that we're going to make mistakes and it's going to happen, and let's have already made a mistake. It says stretches and not stretches like I would like it to. So even though that's bothering me a little bit, I'm just going to add the T in there and move on. Okay, so we're going to talk about stretches and compressions. Okay, so for a stretch, what's happening is it's getting pulled away. When I was little, I remember there were these advertisements for like these wrestling dolls, and you could just like stretch them or stretch Armstrong, but I don't think you guys had that. What about Gumby? You guys remember Gumby, that you could stretch it? Or like sticky hands that stick to the walls, where you stretch it as far as possible. So we're going to think about what happens to the graph when we stretch. What happens to the points is the points are being pulled away. Okay, now for something that is horizontal, okay, these are actually going to be affecting the y-axis. But it's the x-coordinates where we're applying a multiplier. Okay, so the x-coordinates, the x-coordinate is going to be multiplied by some constant value. For this particular rule, it is called b. Okay, and that multiplier actually has a few rules. The multiplier it either has to be greater than 1, okay, so larger than 1, or less than -1. So the negative doesn't matter. We're going to be looking at the absolute value. Do you guys remember looking at any stretches or compressions of graphs in Algebra 1? Do you guys remember what types of graphs you would have looked at them with? If anything, it would have been a parabola. Do you guys remember the parabola with the quadratic? So we're going to use that as our example. So what happens is points are pulled away from the y-axis. Okay, in a stretch, the points, that's PTS, that's my abbreviation. Points are pulled away. Say, we grab a motion. Okay, so the points are pulled away from the y. And we're going to draw some sketches. This will be a great quick reference for you so you can see what happens in these different situations. For every one of our quick graphs, we're going to be using a parabola that opens downward. Okay, and I just want you to imagine if you were pulling points from this away from the y-axis, I just want you to think about, would this make the graph narrower or wider? Okay, so just think about, would it be narrower or wider if they're being pulled away from the y-axis? Do you guys have any guesses? If I'm pulling these away, what's happening to the graph? Yeah, it's getting wider, right? So think about vertical. I'm vertical right now. So if you were pulling my arms, I would just get wider, right? Same thing happens to this graph. Okay, so we're going to draw that. And then we're just going to put a nice little reminder there. It's getting wider. Something that you can look at quickly and say, okay, that's what's happening. Now remember, we got to apply the rules as well. So when you see the rule, it's going to be xy. Start with xy, always free from rules. And then what happens is the x-coordinate is multiplied by what is called b. Again, b can be any number. It's usually a constant value. Well, it is a constant value. So it's bx comma y. So your y is going to stay the same. It's the x values that change based on the multiplier. But there is a stipulation on that multiplier. It's where the absolute value of b is greater than 1. So this might be a symbol that you haven't seen in a little bit. It's the absolute value. Those two straight lines of B is going to be greater than 1. All right, and we're going to stick with the horizontal, okay, because the horizontal is going to affect the y-axis. In a compression, it is pushed towards that axis. Okay, so for any compression, they're being pushed towards. For horizontal, it'll be towards the y, vertical, it'll be towards the x. And then the multiplier for this is between, so VTW, it's between 0 and 1, or -1 and 0. Well, what does that mean? What kind of values are between 0 and 1, and -1 and 0? Decimals, right? Decimals and fractions that are between 0 and 1. Okay, good. So points for this one are pushed toward the y-axis. So again, let's look at this visually in terms of a graph. We'll draw the same downward parabola. And the compression is I'm pushing that towards the y, right? So instead of getting wider, it's going to get narrower. So understanding what each of these does is going to be really helpful when you start to graph. Because you can say to yourself, you know, you plot your points and you're like, wait, this is supposed to get wider, but that's not what my points did. So you'll be able to assess whether you're doing the problem correctly. So for this one, the rule is almost the same. The first part is the same. Okay, you're still multiplying x by a value of b. It's just there's different rules for b. If it's a compression, the absolute value of b is between 0 and 1. So the rule is the same, it's just different specifications for b. So the absolute value for a compression has to be between 0 and 1, whereas for the stretch, it will be greater than 1. Okay, now for the vertical, that is going to affect the x-axis. Okay, so it's the opposite, right? We know vertical is the y-axis, but it's affecting the x. The multiplier is applied to the y-coordinate. And for this type, the y-coordinate is multiplied by what they call the value of a. And again, those can change from textbook to textbook. It's just our textbook uses a as the value. All right, so for this one, the points are pulled away from the x-axis. So again, we'll think of our parabola and we'll just start thinking, okay, if I'm pulling that away from the x-axis, is that going to get narrower or is that going to get wider? So before we were pulling away from the y. Now we're going to be pulling away from the x. Okay, so if I pull these away, it's going to be getting narrower. Okay, so if I pull this, right, it's going to be going more that way. So it might look something like this. Okay, so I'm pulling that up. And then let's do our rules. So this is x, y. This is where your x stays the same. And then the y is multiplied by a. Now the value of a has to be greater than 1 when you take the absolute value. Alright, and then just based on pattern, because I have a feeling you guys are pretty good at picking up on patterns, I feel like you could fill in this last box, right? So for this one, the points are pushed towards the x-axis. Okay, so if I'm pushing towards the x-axis, right, just think, oh, I'm pushing this down. If I'm pushing that down, this is going to get wider. And then just like last time, the rule stays the same. It's just the stipulation on your value of A is what changes. So again, for vertical compression, anytime there's that compression, that's where we have to be between 0 and 1. Okay, so 0 is less than the absolute value of A, which is less than 1. And that is where we will bookmark for today. We will finish up that last example tomorrow. And then just depending on your class meeting, some of you are going to be in here for the full time, and then you have time to work on your homework. If not, that'll be something that you do at home. And it will be on graph paper. So if you're a sophomore, you're going to miss some of class tomorrow, so if you wanted to start on your homework tonight, I have that on the class calendar for you.